Great. So I'm Ismael Garrido, and we'll be talking about just-in-time transcoder. So what's the challenge we had? We had one customer ask us for help in previewing big video files. They have studio quality files, which are usually pretty big. And since many people now are working from home, they need to be able to quickly preview those files remotely. So the users might not want to download a 200 gigabyte file to produce just a few minutes here and there. So our thought was, let's turn those files into a VOD. So we make them able to seek to the file and only download those pieces that they need. How do we do a VOD? We can use HLS. So let's refresh a bit of what is HLS. HLS is HTTP live streaming, one of the most used protocols for live streaming. So how does it work? A video file is split into small short segments of about 5 to 30 seconds usually. We have a playlist, which we call a manifest, which references them and acts as an index to all available files. This playlist indicates how long each segment is, so the player can know the length of the whole media file, and when you seek into the file, the player can know which specific segment does it need to ask for. How do we generate the HLS file? We just take the file and cut it into segments, transcode those segments, and then we assemble the manifest. Since we know how long each segment is, we have the whole list of all the segments. So faced with this challenge, we sat down with the whole engineering team and began thinking possible solutions. We came up with several ideas and we iterated on those ideas. I'm going to show you how we evolved our ideas for the design of this solution. So the first idea we had is, okay, let's just transcode the whole file when we get a request. And then we'll have the HLS ready and you can watch it afterwards. What issues does this design face? First, transcoding is slow. In my laptop, for instance, it does about 2 to 8 times real time into lowest quality possible. So depending on the input file and which code it has and what output quality you want, if we have a 2-hour movie, it will take at least 15 minutes to be ready. Now, granted, a mega server might be about 10 times faster in the rest of the cases. So the user will only have to wait about 1.5 minutes if nobody else is processing a movie right now. This waiting time seems too long for a good user experience. We also need a cache for the transcoded files. We'll need to decide how much space to dedicate to that cache. We'll need to handle the expirations. And the whole cache has to be big enough to hold the whole movie and big enough to hold it for as long as the user is watching, or else we just have to restart the whole transcoding again because we expired it out of the cache. So with this, the first question we had is, okay, but what if we have many users and one server is not enough? How do we scale that service? Okay, so we'll add workers, which will do the transcoding. We'll have an ingress server, which will handle the cache and distribute the user requests. And we'll have a queue, which the workers will process and then notify the user that the file is ready. So which issues does this system still have? Okay, first, the transcoding is still slow. Then the system is now a bit complex. Programming task use is usually no fun. because there are several edge cases to consider, most of them revolving around on what happens if a worker dies in the different stages, like it just got the task versus the task was ready, but the worker already had the file, or the worker already processed the output file, or some of those output files. So many failure states that you have to consider. We also have to decide where we store the intermediate files and how the user gets access to them. And we have to handle all the single points of failure, in this case, the Ingress server and the queue. So we thought, okay, can we improve on this? And here we thought, wait, why are we transcoding the whole file when the user just wants a few seconds of this? So let's do just-in-time transcoding. When we get a request, just in time, create the manifest or chunk as needed. So generating the HLS manifest, which is the file that says which segments are available, is the slowest part because we have to analyze the whole file to extract the interesting keyframes. But afterwards, getting a chunk is quite fast since we only need to transcode a few seconds at a time. All the information we need to create the chunk is on the manifest itself. So we have a stateless system. The big advantage, we don't need to manage a cache. The user will get the segments quickly and can seek anywhere almost instantly. And the whole system config becomes pretty easy because we don't have to store the intermediate files, figure out how to serve them, because the same request that came in, we just give the answer almost instantly. We also get a free API, because what do I mean by this? The API is pretty transparent. The user just has one URL, which it uses to request the manifest. But since the manifest has all the chunks, and we do the transcoding when the chunk request arrives, so the player will just go ahead and do the request when it wants. Those are actually our API to transcode. The only issue we have is that the manifest can take a bit to generate. In my test, a 2-hour movie, it takes about 30 seconds to generate the manifest. So let's see a quick example of our API. So the API begins with the player requests a manifest. You can see the get request with the path to the movie we want. In the response we get, we'll see the M3U tags for the HLS playlist. And each segment will have an extinf tag that will say how long the segment is. On that path, we'll have all the information we need to create that chunk when we need it. So we'll have, for instance, a segment number. We'll have the decimal bit rate in kbps. We'll have the start and end of the video's timestamps we need for the transcode, and the start and end of the audio chunks. So all the information we need to be able to transcode this specific chunk is on the URL for the chunk itself. So based on that extinf tag, the player knows that if you want us to play from time 15 seconds, it just needs to request the segment number 1 and continue from that point on. When the player requests that chunk, we only then transcode the file and only in that specific time frame. So in this case, for instance, we didn't need to transcode the segment number 0 because the user never wanted to watch that. So coming back to the design, how do we scale this? Now, so since the API is pure HTTP, we can add Varnish. Varnish is a caching HTTP reverse proxy. It can handle all the cache logic, and we can use it as a smart load balancer. In Varnish, it's pretty easy to create rules saying this content or this path is to be handled by this pool of workers, which also give us the flexibility of, say, this pool of workers might be in another data center, if that's an issue. Varnish itself is very performant, so it can saturate the link on normal hardware, but if needed, it's very easy to add more and avoid having any single point of failure. The manifest is still an issue because FFPro has to scan the whole file. But we can mitigate this. If this wait is still too long, we can regenerate the manifest because they are very small and very easy to cache. So how do we implement this? So for a proof of concept, we create a node server which will run FFPro to generate the manifest for each file. And then when a chunk is requested, it will run ffmpeg to cut and transcode the segment of the file we need. Which brings the question, where can we cut the original file? So let's remember the structure of a video file. In particular here, I'm going to be talking about H.264. So H.264 video has I, P, and B frames. I frames are encoded independently of other frames. B frames use information from the previous I or B frame, and B frames use information from previous or the next I or B frame. The important ones here are the I frames, and these are called key frames. The whole self-contained structure is called a group of pictures, or GOP. And that means we can decode a GOP independently from other GOPs. And usually the size of a GOP is about 10 seconds. So each GOP is pretty independent. This feature allows us to seek quickly inside the file and only decode what we need from the file. To find those keyframes on the file, we run FFPro and tell it to skip all non-keyframe frames. That's the no key in the command line. And only on the video stream, that's the select streams B. This will output a file with all the timestamps for each iframe. And these timestamps are what we'll use afterwards to create the playlist. In the case of audio, every frame is a keyframe, but some codecs like AAC have some priming data. So to encode them correctly, you have to be careful to give the encoder enough previous data so that the audio can be stitched together afterwards. To get these points in time, we also do FFPro. This time, the only difference is we select the audio stream. With the timestamp from both the audio and video, we can create the manifest. Then, when the user gets and requests a chunk, we transcode the files. Here you can see the parameters we take from the chunk URL, those in the colored brackets, VS, BE, AS, AE, B, and S, and the video file itself. We create two TS files, one for audio and one for the video. We chose TS because the TS container is really easy to join together. The simplest way is just to cat the segments together. This could be done more efficiently if we interwove the packets together. So you could start playing as you download. But in this case, we just wanted to keep it simple since it's just a proof of concept. So you have to download almost all the segment to be able to begin play. Let's do a small demo and hope nothing fails, as demos usually do. Okay. So I'm showing the web page for the player, and here I just gave a path to one file I downloaded on my computer. And when I call load, this will go to the backend server and begin the process to pass the file. Of course, it's bigger file. When we do the first get, what we get is that chunk list, every chunk saying, okay, this is the start of the video, this is where it ends, and these are the pieces of audio you need to get. If I skip ahead, and this is where demos fail. If we skip ahead, and now it works, you'll see that it began playback almost immediately because it only had to transcode a very few seconds to be able to show me the video. And that's all I have. Thank you for listening. If we have any questions, I'll be glad to try to answer them.